Hello, hello, hello. 1.2 trig functions unit circle. First, when we're talking about the unit circle, we're talking about the parent function of an equation of the circle. So x squared plus y squared equals 1. So when we're on the unit circle, this is what we're always going back to. So yes, these numbers that fall on the edge of the circle here that we will talk about will change if the x had a plus or minus, the y had a plus or minus, or if it was equal to a different number. But it's easiest to start at one spot and then notice what our transformations could be from that. So first, when we're in the xy plane, whenever we have sine, that's always going to be y equals, or sine of an angle is the y, cosine is the x, and tangent is the y over x. So first, when we're talking about the unit circle, we should always resort back to our special right triangles that you first started back in geometry. So remember, geometry and trigonometry are both having the study of right triangles. So in a 30, 60, 90 special right triangle, this pattern is always the same. So across from the 30, we have 1s. Across from the 60, we have s squared 3. And across from the 90, we have 2s. Now, what's important, because we're dealing with the unit circle, so our radius here is always going to be 1, we're really just looking at the 1, square root 3, and 2. So when you're ever dealing with this, this is what you should always think back onto. Or else we have the special right triangle of 45, 45, 90. So across from the 45s, because they're the same, my side lengths are always the same. This is L and L, so again, because of the unit circle, this is like a 1 in front, and then we have a square root 2. So let's get back to this right here. Let's say if I have a angle, and I say that this angle right here is 30 degrees. So how can I use my unit circle to help me slash my special right triangles? Well, if this is 30 degrees, this right here, my opposite is going to be 1. Again, if this was 30 degrees, my adjacent is going to be square root 3, and this is going to be 2. So now because I know this, I know my sine is going to be equal to my y value. So sine of 30 degrees is going to be my opposite over my hypotenuse, so 1/2. My cosine of 30 degrees is going to be equal to the adjacent over my hypotenuse, so square root 3 over 2. And my tangent is my y over x, so my y over my x. Now, one thing, when you divide by a fraction, that's the same thing as multiplying by its reciprocal. And then when we have this, these 2's will cancel each other out. You should always make sure to leave your answer without the square root in the bottom. So we'd have to rationalize this square root 3 over square root 3, which will be equal to the square root 3 over 3. Okay, so that's kind of our thinking process for all these problems. So for this first one, when I want to evaluate pi over 6, this is where having this handy dandy, and we will go over this unit circle that you can fill out in class will help you. So if a pi over 6, that's also equivalent to my 30 degrees. So we just did sine, cosine, tangent of that 30 degrees. So now if I want the other 6 trig functions, sine and cosecant are reciprocal, so this would be 2 over 1, or just equal to 2. Cosine or secant of t, the reciprocal is 2 over square root 3. But again, I don't want to keep that square root 3 on the bottom, so I have to rationalize that. So 2 square root 3 over 3. And last one, I could take the reciprocal of that. However, this should be a 3 right there, sorry. If I go back to this right here, this is where we rationalize that. So if I flip the reciprocal of that, that's just going to be square root 3. So cotangent is going to be just the square root 3. So right now, I want you to try to do B by yourself. Now, 5 pi over 4, if I look at this, 5 pi over 4 is going to be right here. Okay, so first I have to find my reference angle. So I'm going to help you figure out what your reference angle, and then we'll go into what the actual sine, cosine, tangent is. So my reference angle, since it's right here, is this angle. That's 5 pi over 4. We have to figure out what just this angle is. So if I need to figure out that angle, I have to minus the 180 from that, so I can figure out that reference angle. So if I have 5 pi over 4, subtract pi, That's 4 pi over 4. So that would be pi over 4. So now I'm really dealing with the right triangle right here. That's going to be pi over 4, which is 45 degrees. So that's 1 square root 2. Okay, so when I'm doing my sine of my angle is going to be my opposite over my hypotenuse. You have to rationalize that. So that would be square root 2 over 2. My cosine is going to be my x value. So that would be 1 over square root 2, which will be square root 2 over 2. And my tangent of my angle is going to be my opposite over adjacent, which is going to just be 1. So pause the video, and I want you to come up with the next 3 by yourself. Okay, but now we have to bring it back to this angle right here. So this angle right here, my x value was negative because I moved to the left, and my y value is negative. So when I'm looking at these, my x value is negative. Sorry, that was my y. My y value is negative, my x value is negative. Both of these were negative, so that makes it a positive. And if this was negative, then my cosecant and my secant would be negative. So it always goes back to the original to look at your positive, negative. Now, if you had trig before, there's a nice little saying that Sharpen and Shalene have said, all sad turtles cry. So if you want to look at what's positive, in the first quadrant, all numbers are positive. In the second quadrant, only sad sign is positive. In the third quadrant, turtles is only positive, which we showed that to be true. And the last, only cosine. So all sad turtles cry is a nice way to figure out which one is negative. So right now, I want you to try to do C and D by yourself. So sometimes also, if you look at these, I found the point at that spot. So remember, cosine is your x, sine is your y. So when you're filling that in, that sine and cosine tangent for pi, when I redo my reciprocal, 2 undefined show up because we have 1 over 0, which you can't have. And if I have a negative pi over 3, that means it's going in the opposite direction. It's going clockwise. So these are your 6 trig functions. Now, one thing that you might have noticed is that when we're doing it with pi over 6, pi over 3, 30, and 60 degrees, remember, those are going to be very similar because of our 30-60 special right triangle. Okay, domain and period of sine and cosine. Now, because of the circle, again, we are basing it always off the unit circle. Because of the circle, it just keeps on going around and around and around. That means that we can get these numbers in multiple locations because we have coterminal angles, because we can either add 2 pi or 360 to something, and it's a different angle, but it's going to be the same measurement. So when we're talking about the y has to be, again, y is associated with our sine, is in between our sine of t. So our y value is always going to be in between our sine. And then that means our x is always going to be in between our cosine value of t. Now, when we're talking about our periods, that means that it's going to be, because it's always going to be circling around, we have something that can always happen with our 2 pi. Because remember, 2 pi is 1 full circle around. So another way that we can typically look at this is when we have a sine of something. So typically an angle that's given plus now the 2 pi n. Now n is going to, we'll talk about our n in the future, or our cosine, because this is going to be taking care of every single time that we add or subtract a value. This is kind of like when we're talking about our periodic function, when we're doing multiple circles around. And then we have even and odd trig functions. Cosine and secant are going to be even, meaning if it's negative on the inside, that means it's going to be the same thing, okay? If it's negative on the inside here, it's going to have the negative on the outside. So if it's negative on the inside for a cosine or secant, it actually just remains positive stuff. However, for sine and tangent, if it's negative, it stays as a negative. So looking at this question, use the period of sine function to evaluate 13 pi over 6. So what I'm talking about is we can have sine of 2 pi plus pi over 6. So it's kind of like finding a coterminal angle. Pi over 6 will be equal to 13 pi over 6. So this is going to be equal then to just evaluating the sine of pi over 6. So remember, pi over 6 is our sine is our y value. So this is like 30 degrees, so across from our 30 is equal to our 1, and our 2 is our hypotenuse. So sine of 13 pi over 6 is going to be equal to 1/2. So I want you to try to do the same thing here. I'll help you rewrite this first. So cosine of negative 4 pi plus pi over 2 will get us our negative 7 pi over 2. So I want you to pause the video and try and evaluate that. So your answer here should be 0. So I'm sorry, I did not write this question for C correctly. This should have been given that this right here, negative to a negative, so evaluate. Sorry that I forgot to write in those negatives. So if we go back up here, sine is odd. So if it's negative on the inside, it's negative on the outside. That means if I just had sine of t, that means whatever shows on the inside is also the same type of thing that will show on the outside. So since this is positive, that means that this is going to be evaluated and it will be also positive. So last but not least, we're going to use our calculator. Now this is not something that I want you to get used to, but this is a great way to check your answers. Now when you're using a calculator, especially since we're going in between two different formats, degrees and radians. If I push my mode button, right now I'm already in radians, which is great because this is in radians. So if I'm going to evaluate sine at 5 pi over 7, I need to make sure I'm in radians. So I can just type in sine 5, and then my pi button's right here. So I'm going to go second pi divided by 7. So my answer for this one, rounding it to 4 decimal places, will be 0.7818. So for this one, if it does not say it's degrees, then you have to assume that it's in radians. So this is also in radians. Sorry about that glare. So now we have a cotangent. We don't have cotangent on our calculator. However, we are smart individuals, and we know that cotangent is the same thing as 1 divided by tangent. So if we do 1 divided by tangent, you have to make sure to close that parenthesis. That's the same thing as cotangent. So this would be 0.0709. And there you have it. 1.2. Have a brilliant, have a wonderful day.